There is a complete and separate flight instrument and navigation system for each pilot. 2 VHF navigation radios provide VOR or ILS inputs to their respective horizontal situation indicators, HSIs, and to the computers used for autopilot and flight director operation. Control panels for the VHF navigation radios are located on the aft control pedestal. Selected frequency is read in the indicator windows. A master volume knob for each receiver is located on top of the frequency selector. It should remain in the full increase position. The number 1 VHF navigation receiver supplies information to the captain's HSI and to the number 1 or single pointers of both radiomagnetic indicators, RMIs. The number 2 VHF navigation receiver supplies information to the first officer's HSI and to the number 2 or double pointers of both RMIs. The information supplied to the horizontal situation indicators is course deviation and to from station location. 2 separate distance measuring equipment systems are installed. Each system is automatically tuned when the associated navigation receiver is tuned to a VHF navigation frequency with compatible distance measuring equipment. When the distance measuring equipment switch is in standby, the unit is warming up, but the interrogator is not operating. In the DMET position, the interrogator is activated. 2 types of DME indicators may be installed on the B727. On the segmented lights type indicator, the loss of electrical power is indicated by a blank display. The dim range knob allows manual control of the indicator light's intensity. On the magnetic wheel type indicator, a red flag covers the digits if electrical power fails. On both types of indicators, dashes indicate searching or lack of signal. ILS localizer frequencies are also tuned on the VHF navigation control panel. A glide slope receiver for each navigation receiver is automatically tuned when a localizer frequency is selected on the associated navigation receiver. Provisions are made for 2 separate ADF radios. However, only the number 2 ADF is normally installed. The panel incorporates a tuning knob, band selector, and tuning indicator for tuning frequencies within 3 bands. The beat frequency oscillator, or BFO switch, on this model provides an audible tone to assist in tuning. The station is most accurately tuned when the tone is at a minimum. The off position of the function selector turns off the ADF radio. In the ADF position, the automatic direction finder is activated. ADF information is presented by the double pointer on the RMI when ADF2 is selected. The antenna position allows operation as a conventional receiver. In the loop position, the loop antenna can be manually operated with the loop knob. The gain knob controls the receiver volume. This is the VOR ADF selector switch. Since the number 1 ADF radio is not normally installed, the number 1 VOR ADF selector is guarded to the VOR 1 position. The number 2 VOR ADF selector, when positioned to VOR 2, selects the number 2 VHF navigation radio as a source for data of the number 2 pointer of the associated RMI. When the selector is positioned to number 2 ADF, the number 2 ADF radio is selected as a source of data for the number 2 pointer of the associated RMI. 2 complete independent slaved gyro compass systems are installed. Flux valves in each wingtip sense the Earth's magnetic field and transmit signals to compass amplifiers and directional gyros for presentation in the cockpit on the HSIs and RMIs. Magnetic information from the number 1 flux valve located in the left wingtip is fed to the number 1 directional gyro, to the captain's HSI, and the autopilot for heading information. The captain's HSI supplies heading information to the first officer's RMI card. Heading and course information from the HSI is furnished to the number 1 flight director and the autopilot. Magnetic information from the number 2 flux valve, located in the right wingtip, is fed to the number 2 directional gyro and to the first officer's HSI. The first officer's HSI supplies heading information to the captain's RMI card and the flight recorder. Heading and course information from the HSI is furnished to the number 2 flight director. The HSI receives and continuously displays magnetic headings of the airplane under the lubber line. A fixed reference airplane symbol is located in the center of the HSI. A red off flag will appear on the compass card if power is lost to the compass system or if the related directional gyro is unreliable. An annunciator is provided to indicate synchronization of the compass card with the magnetic reference. When synchronized, an alternating dot and cross appear in the annunciator window. A steady dot or a cross indicates a need for synchronization, which is accomplished by pulling out on the heading knob and rotating it in the direction of the symbol until it indicates synchronization. Rotating the heading knob positions the heading bug to a desired heading reference. The heading bug is used to command a selected airplane heading when used with the flight director. The captain's heading bug also provides a heading reference for the autopilot. The course indicator and the course bug show the VOR or localizer course as selected by the course knob. The course bug also supplies course reference for the associated flight director. The captain's bug provides course reference for the autopilot. The VOR test function of the course knob is used by maintenance. Pictorial indication of the airplane position relative to the selected VOR or localizer course is displayed by the course bar, the course deviation scale, and the to from indicator. The course bar rotates with the compass card. It can be repositioned with the course knob and is always parallel to the course bug. The course bar represents the position of the selected course with respect to the airplane symbol. Each dot on the course deviation scale equals 5 degrees displacement from a selected VOR course and 1 1/4 degree displacement from a localizer center line. The to from indicator shows to or from the selected VOR station. It is removed from view when an ILS frequency is selected. The glide slope bar displays the glide slope position with respect to the airplane and is in view only during ILS operation. It always remains horizontal and moves up or down the glide slope scale. Each dot on the glide slope scale equals approximately 1/3 degree displacement from the glide slope. A yellow nav-off flag appears when the VOR or localizer signals are unreliable. The flag also appears during an ILS test. A red and yellow glide slope flag appears in place of the glide slope scale if the glide slope signal is unreliable. The flag also appears during an ILS test. An RMI is installed on the captain's and first officer's instrument panels to the left of each HSI. The RMIs display airplane magnetic heading. The captain's RMI card is a repeater of heading information from the first officer's HSI, and the first officer's RMI card is a repeater from the captain's HSI. A red off flag appears if power fails or when the opposite HSI off flag is in view. The number 1 and number 2 pointers on the RMI are associated with the number 1 and number 2 VHF navigation receivers. The number 2 pointers also show information from the number 2 ADF receiver. They indicate magnetic bearing to the station received by either the VOR or ADF receivers. Here, with both selectors positioned to VOR, both pointers indicate magnetic bearing to the VOR stations. In this illustration, the number 2 selector is in the ADF position. The double pointer will display magnetic bearing to the station tuned on the number 2 ADF receiver. Whenever a VHF navigation receiver is tuned to an ILS frequency and the associated selector is in the VOR position, the pointer moves to a horizontal position across the face of the RMI. There is a magnetic compass installed on the windshield center post. The compass indicates the heading of the airplane in relation to magnetic north. The correct answer is C. The number 1 compass system is associated with the captain's system and the autopilot. A crossover system provides heading information to the first officer's RMI card. The correct answer is A. An unreliable directional gyro or electrical power off will cause the red off flag to appear. The yellow off flag is associated with the loss of power or failure of the navigation radio. The yellow and red glide slope flag indicates glide slope signal is unreliable when an ILS frequency is tuned. The correct answer is B. The first officer's heading bug provides heading to the number 2 flight director only. The pitot-static system has 3 heated pitot probes. The probe on the left side of the fuselage is for the captain's system. The 2 probes on the right side of the fuselage are for the first officer's and the auxiliary systems. 3 heated static ports are installed on each side of the fuselage for the captain's, first officer's, and auxiliary static systems. A 4th unheated static port on the right side of the fuselage is for the equipment cooling differential pressure switch. The static port heaters must be operative for takeoff in standing water or slush if the ambient temperature is 35 degrees Fahrenheit or below. The captain's system provides pitot and static pressure to the airspeed indicator and the number 1 air data computer. It provides static pressure to the vertical speed indicator and the standby altimeter. The first officer's system provides pitot and static pressure to the airspeed indicator, the number 2 air data computer, and the number 2 Mach airspeed warning switch. It provides static pressure to the vertical speed indicator. The auxiliary system provides pitot and static pressure to the number 1 Mach airspeed warning switch, Mode A and Mode B. Auxiliary static pressure is provided to the cabin altimeter differential pressure indicator and the cabin pressure controller. The auxiliary static system can be used as an alternate source for the captain's and first officer's static systems. 2 static source selectors located on the captain's or first officer's sidewall panel allow selection of the auxiliary static system to provide static pressure in the event of a malfunction of the normal system. 2 air data computers are installed to provide static pressure, altitude, and airspeed data for various instruments and systems. Here is a list of the systems and instruments for each computer. Indicated Mach and airspeed are both shown by the airspeed pointer on the airspeed indicator. The red and white VMO pointer indicates maximum operating limit speeds. External airspeed bugs are manually positioned to desired airspeeds. An internal airspeed bug, shown at the 6 o'clock position, is controlled by the airspeed bug knob on the lower left corner of the instrument. The internal airspeed bug indicates the airspeed set with the airspeed knob and also supplies airspeed information to the Collins flight director. The Mode A and B selector on the lower right corner of the airspeed indicator is used to set the maximum operating limit speeds when the airplane is operating in the primary or alternate 2 configuration. With the selector in Mode A, the VMO pointer is positioned to the normal or high maximum operating limit speed. Mode A is used when the airplane is operating in the primary configuration. When in Mode A, the VMO pointer will indicate 380 knots at sea level. At 20,000 feet pressure altitude, the VMO pointer indicates 409 knots or Mach 0.87. With the selector in Mode B, the VMO pointer is positioned to the lower maximum operating limit speed. Mode B is used when the airplane is operating in the alternate 2 configuration. When in Mode B, the VMO pointer will indicate 350 knots at sea level. At 20,000 feet pressure altitude, the VMO pointer indicates 364 knots, or 0.78 Mach. In Mode B alternate 2 operation, the VMO is less until reaching 0.90 Mach at approximately 26,500 feet. Above that altitude, the VMO pointer calibration in either Mode A or B corresponds to 0.90 Mach, which is the maximum operating Mach, or MMO. These speed limitations are listed in the flight handbook. Cockpit aural overspeed warning devices are activated when VMO or MMO is exceeded. Warning aurals can be silenced only by decreasing the airspeed below MMO-VMO. There are 2 separate systems. The systems can be tested by the Mach airspeed warning test switch. Here are the Mach airspeed warning test and the airspeed warning switches. They are located on the captain's instrument panel to the left of the airspeed indicator. Mode A allows the number 1 and the number 2 overspeed warning clackers to sound when the normal or high maximum operating limit speed is exceeded. Mode B connects an airspeed sensor of lower value to the number 1 overspeed warning clacker. The number 1 clacker sounds when the lower maximum operating limit speed is exceeded. The number 2 overspeed is not affected and sounds when the normal or high maximum operating limit speed is exceeded. The true airspeed indicator shows true airspeed derived from the air data computer. The indications are not accurate below 200 knots. A black off flag indicates failure of the signal from the air data computer or loss of electrical power. The IVSI, or Instantaneous Vertical Speed Indicator, is designed to reduce lag in vertical speed indications. The pointer shows vertical speed in feet per minute. On the electric altimeter, the digital indicator shows the altitude in increments of 20 feet derived from the associated air data computer. Below 10,000 feet, the extreme left digit space is solid green. The altitude bug knob in the lower right corner sets the altitude bug to remind the pilot of a specified altitude. The baro knob adjusts the altimeter setting. The captain's baro knob also provides the altimeter setting input to the altitude alert system. The off flag covers the left digits when the air data computer fails or power to the instrument is lost. A standby barometric altimeter is installed on the center instrument panel to provide altitude information in the event of an electrical failure. The altimeter is equipped with a self-contained vibrator to prevent error caused by mechanical friction. The correct answer is B. The number 1 Mach airspeed warning switch receives inputs from the auxiliary pitot-static system. The equipment cooling differential pressure switch receives static inputs from an individual static port. Answer C is correct. An altitude alert panel is located on the forward control pedestal. A beeper on the overhead panel and altitude alert lights on the captain's and first officer's instrument panels provide alert indications. The altitude alert knob is rotated to set the alert altitude. Pushing and rotating the altitude alert knob allows testing of the 300 and 900 feet alert indications. Black and white cross-hatching appears in place of the first digit below 10,000 feet. The captain's altimeter provides corrected barometric altitude to the altitude alert system. An off flag covers the last digit with loss of essential power or loss of the altitude signal from the captain's altimeter. The altitude alert lights come on when the airplane approaches within 900 feet above or below the altitude selected. They go off and remain off if the airplane remains within 300 feet of the selected altitude. A power interruption, such as switching essential power, may cause a false alert. The system is reset by selecting a new alert altitude or pushing either altitude alert light. The altitude alert lights go off individually when pushed. The altitude alert beeper sounds in conjunction with the altitude alert lights when approaching or deviating from the alert altitude. The Ground Proximity Warning System, GPWS, monitors for hazardous flight path conditions and includes visual and oral warnings. It uses inputs from the number 1 air data computer, the radio altimeter, the number 1 VHF navigation radio, the landing gear lever down position, and the outboard trailing edge flaps in the landing position. The GPWS monitors for excessive descent rate, excessive terrain closure, altitude loss after takeoff or go-around, unsafe terrain clearance, altitude advisories, and bank angle alerts. See the flight manual for specific conditions for each warning. A wind shear warning is provided and monitors flight conditions for decreasing performance shears. When the wind shear warning is active, all other GPWS modes are inhibited and remain inhibited until the wind shear condition ceases. The GPWS provides the following warnings and alerts. Wind shear, pull up, terrain, too low terrain, don't sink, sink rate, glide slope, too low gear, too low flaps, and bank angle. When a ground proximity warning is sensed, the GPWS light comes on and an oral warning is broadcast from an overhead cockpit speaker. The oral warning is repeated and the light remains on until the airplane is flown out of the dangerous condition. The fail light indicates computer power failure, self-test failure, or invalid inputs from the air data computer or the radio altimeter. The ground proximity warning system also provides an alert when the airplane is below 1,000 feet radio altitude and more than 1.3 dots below the glide slope. A below glide slope light on the captain's and first officer's instrument panel comes on, and an oral alert, glide slope, is broadcast from an overhead cockpit speaker. The volume of the oral alert is increased below 300 feet radio altitude when descent below the glide slope is more than 2 dots. The glide slope alert is functional only if the ILS frequency is being received by the number 1 VHF navigation receiver and the gear lever is down. Pushing either below glide slope light inhibits the below glide slope alert at any altitude after the number 1 VHF navigation receiver is tuned to an ILS frequency. If the system has been inhibited, it is reset by descending through 50 feet radio altitude, climbing through 1,000 feet radio altitude, returning the number 1 VHF navigation receiver to an ILS frequency, gear retraction, or flap retraction. The ground proximity warning system is tested by pushing the GPWS light. The GPWS light, the fail light, and both below glide slope lights come on. The oral warnings and the oral alerts also sound during the test. The inhibit position of the GPWS flap inhibit switch deactivates only the warnings for flaps not in landing range at 200 feet. This switch is safetied and should be used only when operating under the conditions as specified in the flight handbook. The GPWS conducts a continuous self-test when the airplane is below 10 feet or above 2,450 feet radio altitude. All test functions are inhibited between 30 feet and 2,450 feet radio altitude, or when the descent rate is greater than 3,000 feet per minute. GPWS operation is also inhibited during the radio altimeter test. The radio altimeter indicates height above the terrain from 0 to 1,500 feet. At altitudes higher than 1,500 feet, the pointer disappears behind a mask. The system consists of a single radio altimeter and individual indicators for the captain and first officer. The altitude knob on the right corner is used to set the decision height bug. An amber decision height light in the upper right corner of the ADI comes on when the airplane is descending through 2,500 feet and whenever the altitude pointer indicates below the altitude bug. The DH light goes off and the system is reset when the light is pushed, if the altitude is above the decision height bug setting. When the test button is pushed, the altitude pointer indicates 40 feet and the warning flag appears. The warning flag also appears if the altimeter malfunctions or electrical power is lost. Marker beacon lights provide visual indication of airplane passage over airways fan markers or ILS markers. These lights are installed on the right-hand side of each pilot's instrument panel. The airways light flashes to indicate passage over an airways fan marker or inner marker. The middle and outer lights indicate passage over middle and outer markers. The marker switch selects high or low sensitivity perception of marker beacon identification. The marker receiver's switch on the audio selector panel is an audio on-off switch for the marker beacon audio. It does not have a volume control function and does not affect the marker beacon lights. A total air temperature indicator is installed on the forward control panel. A digital readout of the temperature to the nearest tenth of a degree Celsius appears in a window at the top of the instrument. The off flag indicates instrument power failure, and the pointer indicates maximum climb EPR. Normally, the TAT probe is heated when the left pitot heat switch is on. However, the electrical probe heater is deactivated on the ground by action of the landing gear safety switch. EPR indications are not corrected for altitude and are not accurate above 10,000 feet MSL. A ram air temperature indicator is located on the second officer's panel. The ram air temperature indication may be used if the total air temperature indicator is inoperative. A traffic alert and collision avoidance system, TCAS, includes a Mode S transponder, a TCAS transponder control panel, a computer processor, a combination weather, radar, and traffic display, a voice message system, 2 modified VSIs with red and green light arcs, a highly directional top antenna, and a bottom omnidirectional antenna. TCAS interrogates the transponders of nearby aircraft, tracks the replies, and provides advisories in the event of conflicting projected flight paths. Specific operating information is outlined in the flight handbook and supplemental TCAS training programs. The transponder selector selects either the number 1 or the number 2 transponder and its associated air data computer. With the altitude reporting selector in the ALT position, automatic altitude reporting is provided to ATC. There are 2 code selector knobs stacked together. The outer knob controls the left 2 digits, and the inner knob controls the right 2 digits, displayed in the code indicator. When pushed, the ident button causes the word ident to flash in the ATC aircraft data block display. Failure of the selected transponder would be indicated by the illumination of the red TCAS fail light. It also comes on momentarily during a TCAS test. The TCAS transponder selector is spring-loaded to standby. In standby, TCAS and the transponder are in the warm-up cycle. In test, failed systems are displayed in the lower right corner of the radar screen. In the TA position, the transponder is on, but only the traffic advisory function of TCAS is operational. TA only will appear on the radar display, and a white RA off flag will appear on both VSIs. In TARA, all functions of TCAS are operable. The display is powered even if the radar TR is off. The correct answer is C. This completes Part 2 of the Avionics Systems presentation.